Welcome to EDU World Space.
In problems 99 and 100, we have a cable or ropes attached to one another through rings, and we have 4 segments, and we have points A, B, C, D, and E. Let's see here. I'm going to use A as the origin here. We don't know the vertical component of point B. We know everything about point C. Point D, we also don't know the vertical component. And point E out here at the opposite end where it's attached to the ceiling is 59 feet in the horizontal direction and 4 feet above the origin here. We have, this is FBC, and then this would be FCB, and then this is FCD, and then this is BFDC. If we take our free body diagram of the entire structure here and sum forces over A, B, C, D, and E, so all of these forces, the reaction forces and the external forces, and then some moments about point A, about all of those points. So again, that's this summation here, where I is A, B, C, D, and E here. We can also cut this rope here and look at this, a free body diagram of that subsystem. And we know that that means that FB plus FA plus FBC has to be 0. And then if we take moments about point C, we get this equation. So this will give us 2 equations, a third equation, 5 equations, and then 6 equations. And we can crank through and find the unknowns that we were requested, at least partially. We can get from this set of equations, we can get that YB is 8.67 feet. The tension in this cable here, which we were, I guess we weren't really even asked for that, but I wrote it down here, is 567 pounds. And then the horizontal loads at the ground points are both 548 pounds. Now to find the distance, the horizontal, the distance below below the origin over here of point D, we can take a look at this substructure. Force balances will give us 2 equations. Moment balances will give us another equation. And then we can combine that with the equations for the entire structure and find that, get enough equations so that we can solve for Y sub D, and that turns out to be 7.04 feet. You can also get the tension in this cable, and that's 604 pounds. Now for problem 100, we actually have the exact same analysis, but we'll just have different unknowns in this case. For problem 100, we have that YB is 8 feet here. And we're asked to figure out what P1 is, which in my case, in my figure, is FC. And we also want to figure out what this sag is. So we can use the same equations as we derived before, but now let this force be an unknown. We have an unknown component in the horizontal direction or in the vertical direction, and then we would have this YB is known. So again, we can crank through the algebra, and once we do that, we'll get that FBC is 854 pounds. FC, the applied load, is now minus 658 pounds in the vertical direction. So we have a load here, and it is greater than it was in the previous case. that is because if YB is smaller, basically I think we're pulling this down farther, so this becomes straighter here. So that would move this point up. So again, we're kind of adding more weight here so that it straightens this segment out, because the angle here is going to be kind of dependent on the ratio of these two loads. Likewise, we can figure out the tension in this cable here. The cable from C to D is 916 pounds, and that YD is 6.44 feet. In the previous case, it was 7.04 feet. So again, it has moved up, and that is because as we add more weight here, we're going to have a more straight segments here, and so the angles at point B and point D will be smaller.